Welcome to The Explainer. Today, we're cracking open the mind of a self-driving car. We're going to find out how it learns one of the most basic yet critical skills for any driver, reading a traffic sign.
So let's just dive right in. You and I see a stop sign, and our brains just know what to do. It's instant. But for a machine, it's an unbelievably complex puzzle. The car has to deal with this constant flood of light, figure it out from any angle, in any weather, all while it's moving. So how on earth do you teach a machine to pass that test?
First things first, we really have to get a feel for the size of this challenge. I mean, the visual world out there is chaotic, and for a car that needs to make split-second, potentially life-or-death decisions, there is absolutely zero room for error.
And this, right here, shows you the scale of the problem perfectly. We're not talking about spotting one single stop sign in perfect sunshine. No, it's about learning an entire visual language. Dozens of different signs, speed limits, warnings, you name it, and getting them right, instantly. Doesn't matter if they're faded, partly hidden by a tree, or seen at some crazy angle on a rainy night.
So to tackle this massive problem, the researchers broke it down into two core parts. Pretty simple, right? First, you need a brain. That's the smart software that can actually see and understand the world. And then you need a body, the physical car that can take the brain's orders and, actually do something.
All right, let's start with the most important piece of the puzzle, the brain. This is where the real AI magic happens, where we teach a computer to see and interpret images, kind of like we do. The brain here is a special kind of AI called a convolutional neural network, or CNN for short. The easiest way to think about it is like a digital copy of our own brain's visual cortex. It's not programmed with a bunch of rules like, if it's an octagon and has the letters STOP, then stop. No way. Instead, it learns to spot patterns on its own by looking at thousands and thousands of examples, pretty much the same way a little kid learns to recognize a cat or a dog.
But before the AI can even start learning, you have to prep its study materials. It's a four-step process. First, all the images are switched to grayscale. Why? Because that forces the AI to focus on shapes, not colors. Then, the contrast is jacked up, so all the key features really pop, no matter the lighting. And finally, the computer basically becomes a forger, creating tons of new training images by slightly rotating, zooming, and shifting the originals. This is brilliant, because it teaches the AI to recognize a sign from just about any perspective.
And you can really see the transformation here. I mean, look at that. On the left, you've got the messy, real-world images. And on the right, those are the clean, optimized versions that the AI actually gets to study. It's like taking a blurry, scribbled note and turning it into a perfect, high-contrast flashcard. It just makes it so much easier for the AI to pick out the important patterns.
So what's actually going on inside this AI brain? Well, it's all about layers. Think of it like a team of detectives. The first layers are looking for the simplest clues, things like edges, corners, and curves. The next layers take those clues and start piecing them together into bigger shapes, like circles or triangles. And then the final layers take all of that information and make the final call. Yep, that's a stop sign.
Okay, so we've got a fully trained brain. Now it needs a body. It needs a way to actually move around and interact with the world based on everything it's seeing. And this is what's so cool about this project. You don't need some multi-million-dollar prototype car. The researchers built this thing's body using simple, affordable, off-the-shelf parts. An Arduino board is the controller, with basic sensors to follow lines and spot obstacles. It's a fantastic proof of concept, showing that this super powerful AI tech can run on hardware that's surprisingly cheap and accessible. This schematic is basically the car's nervous system. You can see how all the sensors, its eyes and ears, and the motors, its muscles, are all wired directly into that central Arduino controller, just waiting to get their commands from the AI brain. And this is the moment where it all comes together. The AI brain, with all of its visual smarts, gets plugged into the physical body, finally giving it the power to act. This diagram shows you the whole thing in one beautiful, continuous loop. The camera is the eye. It grabs an image. That image gets sent to the AI brain for a split-second analysis. The brain recognizes the sign, let's say it's stop, and zips a command over to the Arduino. The Arduino then tells the motors exactly what to do. It's that simple. See, decide, act. But how does a digital command, like slow down, actually make a physical wheel spin slower? Well, it's through something called pulse width modulation, or PWM. It's a really clever way of translating the AI's high-level decision into a very precise electrical signal. That signal tells the motors exactly how fast they need to turn. It's the bridge from a digital thought to a physical action. So, after all the training, all the building, we finally get to the big question. Just how good is this car's eyesight? Did it actually pass the test?
The results are, and I'm not exaggerating here, incredible. They tested the AI on the German traffic sign recognition benchmark. This is a standard data set with over 34,000 images covering 43 different types of signs. And it scored an accuracy of 99.63%. I mean, that's nearly perfect.
And just to be sure this wasn't some lucky fluke, they tested it again on a totally different set of signs, the Chinese traffic sign dataset. The result? Even better, 99.68% accuracy. This proves the whole approach isn't just a one-trick pony, it's robust and adaptable.
And this system doesn't just perform well on its own. When you stack it up against other state-of-the-art methods, it consistently comes out on top. It's outperforming other very well-known models, which is just a huge testament to how effective its design and its training really are.
So what does this amazing level of accuracy on such a low-cost system really mean for the future of driving?
Here you can see it working in real time. And it's not just making a guess. Look at those numbers. The system is identifying these signs with confidence levels consistently over 98, even 99%. It doesn't just think it knows what it's seeing, it knows that it knows. And this graph is the final piece of evidence. It's showing the electrical command being sent to the motors, that PWM signal we talked about. Look at it. You can see it spike to 100% when the car sees a speed limit 100 sign. Then it drops to 30 for a slower sign, and bam, right down to 0 when it sees a stop sign. It's a direct, visible link between seeing and doing.
Okay, so this is the real takeaway. The big success here isn't just building one super smart car. It's about creating a blueprint, a method that is both cheap to build and easy to scale up. This could be what makes advanced driver assistance systems, and maybe even full self-driving, available in all cars, not just the super expensive luxury models.
You know, what's so exciting about this is that it proves, with the right data and the right AI, a really complex human skill, like seeing and understanding the world, can be mastered by a relatively simple machine. It just shatters our ideas of what's possible with accessible tech, and it leaves you wondering, what's next?